Hey, and welcome back to Cracking the Cryptic, where we're going to crack some sudokus. So, I've got a bit of time now, so I'm going to do the Super Fiendish, and if I get, depending how long this takes, I might do the killer sudoku, the deadly one, which I've seen has appeared today as well. So, without further ado, let's see how difficult this is. Here we go. So as usual, actually we did get a request, I recall, from somebody to say can we go a bit slower when we're solving some of these puzzles and really step through it, you know, a little bit more methodically. So that's what I'm going to try and do today. You can see all I'm doing at the moment is putting in the pencil marks that we recommend within each 3x3 box. When a number can only go in exactly one of two positions, we mark it with these little pencil marks that you're seeing on the screen. We're going to go about doing that and see how far that takes us through the solve. You can see I've not yet managed to put in one big number. But there we go, there's something interesting I've just discovered. There's a 2, 9, checking these cells, and there's a 9 and a 2 in this column. And this method of notation allows us to find this this sort of configuration, i.e. 2 cells, exactly 2 numbers with the notation. So we now know that no other number can go into these 2 cells. Now that's interesting in and of itself, but it's very interesting when you look at numbers like this 8, because now this 8, although there's nothing in this box or this box, there's no 8 in either this 3x3 or this 3x3. Because this 8 can't go in either of these two positions, we're able to fill in 8s up here like that. And now look what that does in the middle 3x3 box. Boom! This is the only place an 8 can go. Fill in the 8 there. And that's useful for two reasons. Firstly, our notation allows us to immediately fill in a 9 as well. Can also fill in 8s down here. And in fact now we can also see, I hope everyone's watching, this now forces the 3 down into this position. So all of that was really some rather nice, not difficult logic, but certainly I think it showed why this method of notation is quite useful. And here's another reason it's useful that's just coming up now. This is a good solve for us actually in terms of promoting this method. Let me just note the 3s here and then we'll go back to these 5s. So we located a 5 here and we have a 5 here. Now that means that a 5 has to be in one of these two positions. So let's record that. And now you can see again we have in columns 4 and columns 5 we have 2 lots of 5 like this arranged in the same column. Now that means that there cannot be a 5 anywhere else in columns 4 and 5, because if this is a 5, this will be a 5, and if this is a 5, this will be a 5. So there's definitely no other 5s in this column, in these two columns, which means that looking down into this box, we know that the 5 in this box is in one of these 3 cells. And because of this 5, we actually know it's in one of these 2 cells like this. Why is that useful? Well, it happens to be it's useful in and of itself, but look, there's exactly the same configuration with the 7s here. The 7 checks these cells, this 7 checks these cells. So here we find this nice pair here, 5 and 7, which allows us to place the 7 up here like this. It also means And this is the down, or one of the downsides of the notation, although I think we've already in this video illustrated plenty of good sides. These two cells here can only be a 1 or 4. Each of them is limited to being a 1 or a 4. But this method of notation doesn't allow us to write sort of 1, 4 in the box like this, because that would be misleading. That's not what we're using our pencil marks to illustrate. So unfortunately, we'll have to hold off on making use of that fact. What I try and do when I'm computer solving is try and remember it. If I was solving on paper, I would allow myself to mark this in some other way, this 1 and 4 combination. Okay, so well, you can see here there's a 4 here that I need to put in, and now row 4 is very well, all but complete. We have 6, 7 and 8 to place. So the 7, which we've identified in this box, can only go in one of these two positions. Well, actually it needs to go in the top position because we have to have a 7 somewhere in the row. And that means that one of these two is the 6, so obviously it's this way round. This 6 we've already done the logic on, so that's going to force that 6 there. And 8, 8, so that we need to mark in an 8 in one of these two positions like this. We need to place a 3 in this box still. That can only be here now. And we've got 1, 6 and 8 to place in these positions. So we can place a 6 like this. Now technically I'm not allowed to place an 8 yet, because if I did place an 8 in one of these cells I'd have to place 3 8s, which is not the way our notation works. I mean, again, it's one of those things we could just remember in this case because it's so clear. And similarly with the 2 in this. So one thing you could do, providing you remembered it, is to just do this sort of thing here, like this. In fact, we can actually place the 7 here, which means this is a 5 and this is a 2. So we're still making reasonable progress now. Again, this is limited to, this can only be 4 or 9, but I'm not allowed to write that in. Let's see, this needs to be a 3 down here, which enables us to write this 3 in. And something that, you know, is interesting in the context that we spoke about the 1, 4 and how I wasn't allowed to write them in. But if we scan along this column 3, you can see we've got the same thing here. We have a 1 and a 4 that we need to place in one of these two positions. Now, that means that in both of these rows, we've effectively got 2 more numbers filled in. Because, you know, the 1 and the 4 are going to appear in one of these two positions and in one of these two positions. So particularly looking at row 7 here, that would mean we have 6 numbers in the row, and we've got, what would we have? We'd have 2, 8 and 9 to place in one of these 3 cells. You can see this can't take a 2 here, so that means there's a 2 in one of these two positions here. So it gives us in effect another pencil mark, which is, it's not actually going to prove terribly useful. Allows us to place another pencil mark here, but it's the sort of thing that, you know, it could have been extremely helpful. So 2, 8, 9 there. Similarly, we've got the same arrangement here where we have a 1 and a 4, so we've got 2, 3, 6, 8, 9 to place where we know the 6 is over here. So 2, 3, 8, 9. Oh no, sorry, that's not going to work. 2, 3, 6, 8, 9. Just seeing whether there's anything that we can see. I think that has to be a 2 or a 3. But again, that's not going to be quite enough to crack it. Normally at this point it's just a case of spotting the pencil mark that you haven't, you've just neglected to write down, because often when you're doing this, you're not doing it religiously. You're not sort of going through all the 1s, then all the 2s, then all the 3s, etc. You tend to jump around where you find a bit of traction, or I do at least. And that's all very well and good, but it does mean that you miss things like, that was a pencil mark we could have put in a while ago, simply because of all of the givens that we had. And again, this is one of these points where luck comes into the puzzle a bit. So there is, I think, a hidden single here. But spotting it, well, it's really a matter of luck. You have to, you can obviously focus on all of the rows and columns where you have 5 numbers, say. You could do that, and if you just scanned every single position where let's look at row 3, for example, which is where the hidden single is. We know we need to fill 2, 4, 5, 9 into one of these positions. We can see this has to be, I think, 4 or 9. This one's pretty open, this one's pretty open. You get here and you find, look, there's a 4 and a 5, that's nice, so this has to be 2 or 9. Look, there's a 9 already in this thing. So in fact, you could write in the 2 here. Now, it's really, as I say, as I commented yesterday, I think, there is a certain amount of luck with finding that sort of thing. I don't think it's, it's any more, there's any more skill to it than that. I wish I could say that I thought, that sort of thing is in any way related to, somebody's brilliant logical mind, and other than being able to read very quickly, and I'm not sure that I think there's much more to it than that. But that's one thing we needed to find here. That gave us the 2 and the 9 here as well. Interesting, we can put a 4 in up here, like this. And where's that going to take us? Oh, that allows us to put 4s in here, like this. And that's very, very helpful, because now there has to be a 4 in this column, and it has to be here. And that means that this has to be a 1, 1, 8, like that. See the advantage of the notation now. We're able to fill in a lot of numbers very, very quickly there. Sorry, I'm not saying much, because this is really just a matter of going through the motions. There's nothing complicated that I'm doing there. So now the 1 is locked into one of these 2 positions down here. and in fact one of these two positions here, which forces this one into this position. And the puzzle's solved now. I mean, there's nothing clever left to do. We'll just prove it to ourselves that we this is always the point where you really should be careful, because it's very easy to make an error and stuff up all your hard work. This has to be a 4. This has to be a 1. This has to be an 8. 8. 1. 8. 2 9 to place here. This is the 2, and there you go. That's how you do the killer Sudoku, the Super Fiendish variation.